All right, guys, so where we stopped off yesterday was 28 through 30, finding the discriminant and describe the types of solutions and find the value of the solutions. Because we skipped these to look at the value of C. And we did one of these. We can look at another one of these and then go back to it, the discriminant. Do y'all want to do that? Do you guys want to finish up the factors, finding C and factoring it, and then go back to the discriminant? Okay. Powers of I. Addition, division.
No, I thought it was Wednesday. I see a lot of people wearing pink, and I was like, oh yeah, they got the memo fine. Wednesdays, I try to wear pink. Why? Yeah, why? Because so mean girls. I don't even have it.
I mean, Clinton got the memo.
Yeah, well, that's what I said.
Tuesday.
I like to wear the outfit today. I did not sleep.
Okay. That's all. Okay. All right, guys, so I found what I was looking for. So on the test, for not this part, but for the one before, the discriminant and number and type of solutions, it's not actually asking you to solve. I don't want you to solve those. I just want you to be able to tell me what the discriminant's value is. Do we have two real, two complex, or one real? But before we do that, why don't we finish looking at 31, 32, or 33? Because I think we looked at 31 yesterday.
Yes.
And 32, because we finished both of those. Are there any questions on 33? So, because C is equal to B over 2 squared. So for us here, the value of B would be 49 over 2. 49 over 2 squared. Well, will those divide evenly? No. I mean, if you want to turn it into a decimal, you can. Or we can leave it as 2,401 over 4 is our value of C. And if we want to factor it as a set of parentheses squared, it'd be x plus 49 over 2. And that's all it would be looking for. Yes. Yes. Let's look at 28, 29, and 30. Is there one of those in particular that y'all want to look at? 29. Okay, well the discriminant is our b squared minus 4ac. And this is all a part of the quadratic formula. Our negative b plus or minus the square root of b squared minus 4ac all over 2a. So the discriminant is, I'll write it over here, b squared minus 4ac. Now, the big part of this is dealing with the fact that if b squared minus 4ac is greater than 0, we have two real solutions. Now, if b squared minus 4ac is equal to 0, we have one real, and if b squared minus 4ac is less than 0, we have two complex or two imaginary solutions. Now, for looking at number 29, okay. Move these over here. We do need this equal to 0 so we can have the correct values of a, b, and c with their signs. We could get the values, but we may not have the correct signs. So we need this equal to 0. So we can subtract x from both sides, which gives us negative 2x squared minus x minus 6 is equal to 0. B squared minus 4ac. Well, our value of b is 1 minus 4 times negative 2 times negative 6. Now at this point here, we could type this whole thing into the calculator and get an answer. Now if we do this by hand, well, negative 1 squared is 1. Negative 4 times negative 2 is 8. Times negative 6 should be negative 48, which would give us negative 47, I believe. So, what is the value of the discriminant? Negative 47. How many solutions will we have? 2. Now on the test, it's going to ask this in a similar form. It's going to ask to find the value of the discriminant, which we did find, which is negative 47. And
Why do we not do the 2a?
because we're just finding the discriminant. The discriminant is just the b squared minus 4ac. Because it kind of gives us an idea of what kind of values or solutions we will have. Now this is also helpful, especially if you're wanting to try to solve a quadratic equation, because b squared minus 4ac, if it's already set equal to 0, we can plug that in pretty quickly and see, okay, if it's equal to 0, I know I'm going to have one real solution. If it is less than 0, I know it's too complex, so I know graphing and factoring won't work no matter what we do. And if it is greater than 0, there's a good chance factoring will work. We'll have two real solutions. It gives us an idea of what the solutions would be. Now, the other part was, what was it saying in the directions here?
Describe the type of
Solution.
and find the value.
Find the value of the solution. So here it's asking for the value, but on the test it will ask to find the number and type of solutions.
So it's basically this.
Because how many did we have? Well, there's 2, and what type are they? I'm not asking you to find the actual values on the test, because, I mean, you're going to be finding a lot of stuff with values already. This is just dealing with the discriminant and what does it tell us. So on the test, for each one of these, I'm just looking for the value and what does it tell us. What kind of solutions will we have? Questions on this here? Is there another one of these that we want to look at? Sire, do you want to look at 28 or 30? Now, again, like the 29, because this isn't equal to 0, we do need to get it set equal to 0. Not so much that we can't find the values of a, b, and c this way. It just helps us figure out the correct signs. Because a will be 4, but is it going to be positive or negative?
Well, depends on which way.
Yes, because if I subtract the 5x and 10 over, subtract the 5x, add the 10, then it would be positive. If I subtract the 4x squared over, then it would be negative. But are we really trying to solve for anything? No, we're just plugging it into the discriminant, so we can just subtract it from both sides, because it being positive or negative isn't going to be or have too big of an impact. Even if we were reducing the quadratic equation, it being having an a value that's negative doesn't make a big difference. The only time it's really nice to have it be positive is if we are factoring or solving by factoring. Having a negative a value can be a hindrance, or not a hindrance, but it can make it a little harder. So we're plugging it into our b squared minus 4ac. Well, the value b is, I mean, if it was negative 5, it actually won't make that big of a difference on it because of the square. A is negative 4 and C is negative 10. I can tell you right now that we're going to have 2 complex solutions. Because what's going to be bigger? 4 times 4 times 10, or 5 squared? 4 times 4 times 10, yes? Well, we have what? A negative, and a negative, yes? What's it going to come out to be? Negative. So most likely, we're going to come up with 2 complex solutions. And sometimes I will look at that, especially when solving. Well, I look at the discriminant. Well, A and C, one of them is negative. Well, the negative 4 and that negative would make A. So most likely, we're going to have real solutions. So that's one way we can look at it. Here, if we went on and simplified this, well, that would be 25 minus 160. Try to do that again. Which gives us negative 135, so we have 2 complex solutions. And that's it. Questions on this here? Now that brings us to the additional review sheet. The additional review sheet. Now, powers of I. We could type these into the calculator, but again, it gives us that weird error amount. We get either that e to the 12th or e to the 13th added to one of the numbers. Well, sorry, e to the negative 12 or negative 13, essentially 0. The other way to do it is take the power and divide by 4, because if we get 0.25, it reduces to I. If we get 0.50, it reduces to negative 1. 0.75 is negative I, and you all remember what 0.00 is? 1. Which one of these do we want to look at? Okay, so we can take 2,874 and divide it by 4. 18.5. I don't care about 718, but the 0.5 tells me that it is negative 1. We can look at C, because that is I. What's the first number before 41 that's divisible by 4?
40.
It's 1 after it, yes? Well, 1 after 40 would be, because 40 would be 0.00, yes? So 41's I. Because if we did divide it, it would be 10.25. What is 74 divided by 4? It's going to be something, I think, 0.5 if we do. because that would, because 25 times 3 would be 75. 74 divided by 5. What'd you get to read? Yeah, sorry. 18.5. And the reason that works is because if a number is divisible by 4, the last two digits will also be divisible by 4. Because, because 25 times 4 is what? 100. So anything in the hundreds or above will be divisible by 4 because of 100. So really those last two digits really determine if it's divisible or not. So any other questions on this here? I want him. He's probably going to pop up on the other side. So, for the first one here, we can look at A. We want to add our like terms because we're just adding the two together, yes? So 6 plus 4 is? -7 plus -3. And if we think about it that way, it still works, especially if we have two sets of parentheses dealing with that. Now, pick another one with the addition and subtraction. Let's go with, because I think E is kind of funny.
Yeah.
Let's put parentheses. 189 second I minus 361 second I squared. Close parentheses. Plus 71 second I squared. Well, okay. Normally we would, okay, I'll just parentheses 71 I squared minus 38 second I to the fourth. 252 plus 189i.
I think I did put 71 squared. Why did I get
38.
Oh, what did I put?
28. So the calculator can do these just fine and can simplify these just fine. Even if the A plus BI is turned off, it will still work with it.
Why did I get first number being 5,000?
Let me see.
I did something. I didn't put I. Yeah.
Yep. So you can type them in, just make sure that when you are typing them in, that you're double checking and making sure you're typing in the correct thing, because it's very easy to leave something out or put something in incorrectly and get a completely different answer. Yeah. H, 2 plus 3i times 7 minus 4i times 6 minus 2i. Huh? can go on to solve it. Because 2 times 7 would be 14, minus 8i plus 21i minus 12i squared. 6 minus 2i. 26 minus 6i times 6 minus 2i. 6, carry the 3, 156 minus 52i minus 36i plus 12i squared, which is minus, which would be 144 minus 88i. Is that what y'all got? I have a feeling 2, 14, 8, 21. Yep. Because that would be 26 plus 13i. That makes more sense. 6. That'd still be that there. Minus 52i plus 78i minus 26i squared. Well, that would cancel. 26, 6 and 6 is 2. 182 plus.
Oh, yeah, that's it.
Yep. Wrote down a 2 instead of 21. But that's it. I mean, the calculator will do the exact same thing.
Now I have a question.
Yes.
It's L.
Huh?
L.
L?
Oh, you want me to do it?
Yeah. Did I type that in right?
Ah, yes. It's just missing a step. So, any other questions on multiplication before we look at division? So 8 minus 4i divided by 3 minus I. Eight minus 4i divided by 3 minus I. 3 minus second I. So we have to rewrite it with parentheses in our division. Then our next step would be math, enter, enter, to turn it back into fractions. My 2/5 I. And that's it. So we would rewrite it as division, and then math, enter, enter will give us the fractions. Questions on this here? Now, what was the complex conjugate of 2 plus 4i? It's not on there, I realized, because this is on the test, and I forget every year to add it back in, or add it on. And normally I remember, as I'm passing out one of the parts of the test, that this is included on. But the complex conjugate of 15 minus 7i is? That's also why I'm not too. 8i would be? because again, we're really switching over the term with I. And it's really helping us to get whatever the multiple, when we multiply it together, to be positive, to most likely be a positive number, is what we really want to have happen. That's why we're switching I, not the number, the real number. Because we could switch over a real number and end up having a similar thing work out. It just works out that that new number would be negative, not positive, is the only difference. But that's going to be everything that's on the test. Any other questions over any of this here?
What all formulas will we need?
So the quadratic equation would be one for sure. The discriminant and its type setups would be one. Probably definitely making sure that you do have the walkthrough for completing the square, but that is included in the what we went over. And in the key a little bit, making sure for graphing, remembering how to do the calculations for graphing, to pull that up, remembering especially the zero product property. Two or more things multiplied together to equal 0. One of them has to be 0, which we use for factoring. Our powers of I, most of what we went over, because I don't believe there's anything that we didn't cover that won't show up, or anything that we didn't cover that will show up on the test.